almost everyone, right? So do you know that what happens when a single click of a login button? What is the behind of the scenes when a button is clicked, right? So some will say that browser goes to the server and it will go to the database and we will get the response. So in a real IT industry, that single button click travels through a lot of systems before user can see anything, right? So that is all about the today's session. We will understand how the that particular journey went, right? And today we are not learning Laravel, React, Docker, anything. But what we will do is we will learn how everything fits together to build a software which can serve thousands or even millions of users, right? So let's start. So basically, let's talk about the gap, the actual gap. So if I ask a beginner that draw the software architecture, so what they will do is they will be like this tutorial project, right? Browser, then controller, then database. So this is this works with the learning phase, right? It works with the small projects, right? But imagine Amazon, Meta, Swiggy. So that one, they have many architecture, they have many layers, which is this production system, right? Sorry. So these are the layers the actual system software has, right? So these are users, then DNA, DNS, CDN, load balancer, application cache, database, queue, and last is monitoring, right? So we will understand this thoroughly in going forward, right? So basically, this is the complete roadmap of our today's session. What is the actual layers of the software architecture when a single action happens, right? So same, it has users, then internet, then DNS, Cloudflare, load balancer, front end, API gateway, backend, then authentication, Redis, PostgreSQL, queue, storage, monitoring, right? So we will learn this. So let's start with the actual enterprise project structure, right? People sometimes get confused, like they know how to code, right? But it is not sufficient that people should only know the how to coding, right? Now AI can do the coding, right? But we what the important part is we how we will organize that code, right? Basically a project structure. So the standard is there will be a front end, then controllers, then services, repositories, database, right? So front end is like your the front part of the project, right? It will have the pages and components, all those things, right? Where user can interact. And the controllers. Controllers are the layer which receives the request, what you have done from the front end, right? It will pass to the services. So services has the business logic inside it, right? Nothing else. It will pass the logic and it will pass the request also to the repositories. So this repository layer will only be able to talk with the database, right? The above layers, controller services front end does not have the access to the directly to the database, right? So, and then last is the database, where we will have the information. It will retrieve the schema and it will we will get the response, right? So let me show you one actual project structure. So this is a real project structure, and basically it has this. This is the root structure of the project, and it has all the uh, controllers, services, database connectors in one folder. which is SRC, right? So let's go one by one. Let's say this is the controller, company controller, right? So this controller will receive the request from the front end, right? It will receive the request and data which has received from the front end, and it will pass to the service, right? So basically controller is like a bridge. Front end request comes, pass it to the service for logic handling, right? So it will passes to the service, right? And this is the service. Service is a different file and it's a different concept. It cannot be merged with the controller, right? So this is the company's, this is the service. It will have all the business logics in it, and uh, it will have the it will connect the business logic with the database layer, right? So basically this is the model, right? This is the layer where this the service will call the model and model will call the database, right? So there is no direct call to the database. This model layer is there between them, right? So this is how it will, the actual project organization or sorry structure will work, right? So this is the actual life cycle of a particular request, right? So we have this login example, login button example, right? So when a user clicks the login button, browser will create a HTTP request and it will pass to the DNS. DNS is the layer, like if where is the server? I have a request, but where to uh, where to pass it, right? So DNS is there for getting the server information, and HTTPS is the protocol to send the request, right? So then comes the Cloudflare. Cloudflare protects the request against any attacks, right? So it is for the security, and then it goes to the load balancer. Load balancer is like I have 10 servers. So which server should receive this request? So load balancer is for that. Then authentication. Authentication checks the token which is there in the request to authenticate the particular entity, right? And it will go to the controller. Controller receives the token with the request and it will pass to the service. Service will now runs the business logic and it will go to the repository. Repository will call the database, which can be PostgreSQL, MySQL, right? And it will check that if there is anything which is there in the cache memory or a session is stored in the memory, then it will return that response in the JSON format. So this is how a single button click life cycle is that. Now there is two important segments which is there in any project structure, right? So first is authentication. So sometimes people knows the difference when they are building anything, but when it comes to a instant question, instant answering, they get confused, right? So basically authentication is who are you, right? We verify the identity of some entity. That is authentication, right? And we have that identity and what that identity can do, right? What access they have. That is authorization, right? So that is the basic and simple explanation and difference between that. And then it represents the life cycle like login. Login will user will click the login, then it will verify the password. It will generate a JWT token. The client will store the token, and that token will pass to the all the future requests for the authorization. Right. This is how the authentication and authorization happens. Basic layout, right? So now APIs and database design. Now, any, as I said earlier, front end does not have direct access to the database, right? So what is the middle layer? Middle layer is APIs. The request should be passed through the APIs for database calling, right? So API, so nowadays there are REST APIs, there are GraphQL, right? So we will see how REST API is there. So it has this four methods, which is get, post, put, delete, right? So these are the operations of any request. And when we have to call any, we have to do any operation, or for, let's say we have this login button, click, right? So when I click the login button, it will send the request with this particular method, right? Basically it sends the post method, right? And get method is used to retrieve the data only. Post method is used to uh, do operations, pass the data and do the operation. Put method is also for that. We pass the query parameters and another data, and it will do the operation. Delete is, it will uh, it is designed for the delete operation that we do for in the database, right? So basically this API, how does that API work, right? There will be a request, right? And it will be in a JSON format, right? It passes as a JSON format, and that will be written, same that will be written in a response, right? So this is how a request is processed within the front end and backend architecture, right? So now there is a database. This is a crucial part of any software. So basically, when we have this simple projects, and when a beginner is there, they are learning, they will be like separating the entities in a different schemas, right? But those those relations, those tables, what we say, they relate to each other, right? As we have like users are there, so users can be related to the departments, right? One department can have multiple users, right? Employees can be have the departments, right? Leaves can be having the employees, right? So these are the relationships we have to define when there is when we are defining the project structure, right? So now we have we have to think about the performance criteria also when we are building any software, right? So when everything is not happening in the each request, right? Some we have this mechanism which is called Redis, right? So Redis is for the caching, right? Imagine we have 10,000, a million users, right? And only one dashboard. So dashboard is having so much data, right? We have to fetch, we have to get the data from the database, we have to uh, we have to collect the data in each second, right? When multiple users are coming and accessing it. So we cannot call the database every time in every request. So there Redis comes. We store some information in the cache memory through Redis to retrieve the data faster, right? So it stores the data in memory, right? So basically it used for the dashboard things, and where the data operations are heavy, right? And we have this queues. So queue is all about background processing, right? Let's say one user, let's say there are 5,000 users, and they are signing up in a project, right? So at that time we are sending the welcome email, right? So in one click there are 5,000 users, they are signing up in same time, and we are sending the email in real time, but it won't work, right? People will have to wait for that email. So for to overcome that, we have this queue which processed the email in background, right? It will queue the, so basically queue is like having the uh, process each and every part one by one, right? So it will not make the user wait for much time, right? So these are the examples like OTP, welcome email, PDF generation, notifications. There are these. all are the examples of implementing a queue. Right? So now we have Docker and cloud infrastructure, right? So we have implemented, we have built a software, it works on my machine, right? We usually say it works on my machine, but it is not working on your machine. Why? Right? So in a big to overcome this, we have Docker, right? So Docker is a platform where the containers will there and where the same image will be run on different platforms, right? So it will make the stereotype, which is it works on my machine, stop, right? So every dependencies will be, we have to implement every dependencies one time only, right? And it can work on any platform. So that is the Docker and cloud infrastructure, right? So we have this the cloud. We have this cloud platforms, which is AWS, GCP, Azure, and scale these containers automatically under load, right? So cloud infrastructure is all about the storing of the data, right? And getting those data in a quick format and organized format, right? So this is the simpler layout, right? Developer will use GitHub and it will use Docker, and Docker will use the cloud infrastructure, and it will contain the this containers, and then it will be retrieved in users. Right. So this is a basic layout of it. Okay. So now we have CI/CD pipeline. So in old projects and in beginner level project, what we do is we have software ready, we have everything ready. We have to make it live. We have to go to the market. So what we'll do is we will release that. We will sorry, we will deploy that project. But for deployment in beginners project or in old method, we have to download the project in a zip file. We have to upload that on one FTP server, and then it will be hosted, right? So whenever we do any changes in a project, we have to uh, reflect that changes manually by going to the FTP server, and then it will be reflected on the live project, right? So CI/CD pipeline makes this easier. It works with the GitHub, right? When a developer pushes any changes in a Git, and GitHub will sorry, GitHub will do the automated process. So CI/CD pipeline is basically for the automatic deployment, right? So GitHub will do the automated tests. It will build the Docker if Docker is configured, right? And then it will automatically deploy the changes, and the changes are on the production, right? So we don't have to go manually upload the files to the FTP server, and then it will check the build issues and then go live, right? Everything on a one go, everything on a one git push, right? So this is the CI/CD pipeline. Okay. Now we have the software built ready. It's on production now. It How about scaling that application? First, we have some amount of users, some amount of traffic. Now it is getting increased, right? So what actual architecture should be, right? There should be load balancer, right? It spreads traffic across many app servers, right? Then app servers, horizontally scaled, add more, not trigger. Build Redis absorbs read load away from the database. And then DB cluster, primary replicas instead of one instance, right? So these are the background architecture we have to change when we are scaling an application, right? So yeah. So we have this monolith versus microservices. These are the architectural choices. So monolith is one code base, one deployment, right? It is like we have to code one time and we have to deploy it single time, right? But when it is like when there is a changes and we have to deploy, we have to uh, scales the module and we have to deploy together all the modules, right? So every time it is a risk, right? Every time we cannot do that. So that is where microservices come. Many small independent services, right? So adopted by enterprises at real scale, teams own and deploy services independently. Each service scales based on its own load, real operational and network complexity. So this is the risk, right? Basically, microservices are the small independent services, right? It to deploy some changes, we don't have to deploy all things together. We just have to deploy that one small changes, right? And it will be independent. Right? Putting everything together. So this is the closest tech stack when any IT company follows, right? So in front end, there is Next.js, there can be React.js, Vue.js, Nuxt.js, right? And in backend, there is Nest.js, Laravel, Node, Express, right? Database, PostgreSQL, MySQL, MongoDB, caching, Redis, Q, there is this bull and queue, right? And in infra, we have Docker, AWS, Cloudflare, GitHub Actions, right? So this is the category of state many modern SaaS platforms run in production, right? So these are the common mistakes that a beginner makes, right? Fat controllers, right? Business logic everywhere, no validation, no logging, no Docker, no CI/CD, no caching, no monitoring. Each one is a real specific fix, not a vague write cleaner code, right? So this each step is very important when we have to make a good software architecture and we have to scale that software also, right? So the final architecture and key takeaways. So what we have learned throughout this session is users, these are the top layers of the architecture, right? A project architecture. Users will be having the interaction to DNS. They will so users, DNS, Cloudflare, load balancer, backend, auth, Redis, PostgreSQL response, right? So this is the overall architecture, right? So this is a personal opinion or personal experience of mine when I was as a beginner when I started my career in the IT industry. I was like, if I learn any framework, I can be a good developer, right? So I was having this myth, and but that is not true, right? We frameworks will come and go. Frameworks can be learned, right? But what you actually have to learn is the architecture, right? That is independent thing. Every project will have the same architecture, right? It depend, the frameworks will be different, but the architecture knowledge, it is must, right? And it actually helps to be a good developer. It is not only about the good developer, it can be like anything in the IT industry, right? You know the architecture, you can build whatever you want, but not only frameworks knowledge will help, right? So this is the personal experience of mine. I hope we have a good understanding like the real world project architectures, right? So that is it. And if you guys have any questions and answers, right, we are open. So anyone has any questions? Okay. Okay. So yeah, so I think we are good, right? And so let's end this session. Okay. 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 So thank you everyone. Thank you for joining.